All right. Hi. Good morning, Dexter. What are the 3 states of matter?
Solid, liquid, and gas. And don't put this on Facebook.
All right. I won't put it on Facebook. Andy, I know you like to talk about a 4th state of matter. What's this 4th state of matter you're always talking about?
Plasma.
All right. Does that exist on Earth? No. Where does it? It can. Where does it exist?
Electric signs.
Yeah, like in neon signs. And what about nature's electricity? That comes from the sky?
Lightning.
Lightning, that's right.
Lightning is 10 times hotter than the sun.
Isn't that crazy when it actually fires? Because the sun seems pretty hot to me. So how do the different states of matter change?
Different temperatures.
Different temperatures, right.
Like it goes from liquid to solid, solid to liquid, and liquid to gas.
Mm-hmm. So what are those called? So let's start with solid. When solid turns to liquid, what do you call it?
Melting.
When liquid turns to gas, what do you call it?
Boiling.
Or?
What is it? Evaporating.
Evaporation, that's right. Now, when gas turns to liquid, is it usually heating or cooling to make it cooling, right? And what's that called?
What is called?
Condensation.
Condensation,
that's right. And then when liquid turns to solid, is it heating or cooling? And what's that called? Freezing, all right. So what's the difference? How do we define a solid state versus a liquid state? What's special about a solid state that makes it solid? It has a
fixed shape.
That's right.
Yeah.
Fixed shape. That's good enough. It's even gooey things are solid, like some Play-Doh or plasticine might be. You might think that it's a liquid because you can move it, but once you stop touching it, it pretty much stays solid. So that's a solid. Whereas syrup is sticky. What do you think syrup is? A solid or a liquid?
A liquid.
And
it has no fixed shape. It takes the shape of its container.
Takes the shape of its container, right. Gravity keeps it down, keeps it on the bottom. Then the difference between liquid and gas, how are they different?
What?
Liquid, so the state of gas. So how do we know what is a gas?
It has no
shape.
Fixed shape.
Mm-hmm. And does it assume the shape of the container?
No.
What does it do in the container it's in?
It just sits there.
Fills it up, right? Yeah. There's a special transition also. Straight from solid to gas.
Dry ice.
Well, that's what we're going to use today, yeah. But what's it called?
Carbon dioxide. It's already frozen carbon dioxide. It's a gas.
That's right.
So it just turned back into a gas.
Yeah. So melting is from solid to liquid. Evaporation is from liquid to gas. So what is it called? Solid to gas. You remember?
What?
The change from solid to gas directly.
The name?
It starts with a sub.
Subtation.
Nope. Sublimation. Sublimation. Close.
Sublimation.
Yeah, that's the fancy word for it.
Sublimation.
Mm-hmm. And then the opposite, so going from gas straight to solid is supercooling. They call it deposition. Like it's a deposit, like the gas is depositing straight into the solid. All right. You're asking me why I have a potion cup? Because I happen to have one. I think that was from when I was in university and they got rid of it. They're like, we're getting rid of this old glassware. We don't make potions anymore. So,
did you ever mix acids?
Oh, did I? I mixed acids and bases in the basement with my junior chemistry kit. Okay. So, we're talking about sublimation. Right?
Why is there a glove over this?
Oh, yeah. Well, this was going to be... All right, so sublimation. We want to prove that sublimation's a real thing, right? We want to prove that a solid can turn directly into a gas.
What do you mean I get to play with dry ice?
We're going to play with some dry ice today.
You remember the last time I touched it? I literally burned my finger.
Oh, let's not talk about that while the camera's rolling. Look it now. There it is. Now, can you already see some fog coming off of it?
Yep.
Oh, what's that? It's certainly below room temperature. So to this carbon dioxide right now, it's super hot in this room. It's so hot that it's jumping straight to gas. So when we think about this in a jar, right, turning straight to gas, we just assume that the gas is going into the atmosphere. But I wanted to prove to you that it's actually making gas. So what we're going to do is we're going to put this glove on top of this container. And we're going to see if it can inflate the glove. So this glove is it creates a seal, so nothing can escape. And I think you can already see it working. There it goes.
Oh yeah, it is.
So look, the glove is filling up. It's like he's waving to you. Hello, Dexter. I'm carbon dioxide.
Okay, that's weird.
So what do you think is causing that?
Air.
Yeah, it's the sublimation of the
What
of the
happens
carbon
if we
dioxide.
take that off?
Because
It'll probably go flying up into the room.
Yeah, it's
Because
kind
there's
of
so much air because it'll just...
kind of like a balloon. Uh-oh, he's getting bigger.
Oh, man.
We'll
Yep,
just,
I see it. I don't think it's strong enough.
well, we can just, I'm sure it's safe to just kind of leave that over up to the side, and we can watch that for a little bit.
Yeah, until the string
till it
breaks,
explodes.
and then it'll go up into the room and probably break that.
Yeah. So another way we can look at sublimation is, now, think about this, right? The carbon dioxide, that's solid, it's turning into a gas because of the heat of the air. But air moves around really quickly. It itself is a gas. This piece of carbon dioxide, oh my gosh.
Oh my gosh.
That hand is getting pretty big.
Yeah.
Well, we'll just leave it there, see how big it gets. But we're not heating it super fast. What could be a way that we could heat that brick even faster than just leaving it in air?
Boiling it?
That's right. Do you think we need boiling water to make it boil?
Yep.
So we could put it on the stove, and that would heat it up really quick. We could also just put it in some warm water. Now, if we put this carbon dioxide into warm water, do you think that means it's melting? Do you think the carbon dioxide is going to melt, or do you think it will continue to sublimate?
Continue to sublimate.
Yeah, and why is that? Right, remember the... Oh!
Oh.
Uh-oh.
Uh-oh.
Uh-oh. It's
okay,
going.
That's a fat hand.
It's getting ready to take off, I think.
Okay. Make sure that it's out of that reach.
It's trying to pull the elastic. Oh, the elastic went into here. Okay. The elastic's in a pretty good place, so it's probably going to pop before anything.
Okay, yeah. I'm just gonna plug my ears.
Do you want me to release it? So, oh yeah, and now just to make it easier to see, we should probably put some food coloring in our water. What color would you like?
Red.
Oh, of course. Favorite color. So, could you help me and put some red food
How
coloring
many?
in there? Just 2 or 3 drops is enough for this one. Okay.
I'll do 3. 1, 2, 3.
Okay. There we go. We got some red. Now it really looks like a potion. And this is actually, for you movie fans out there, this is sort of a way in which...
it's turning purple.
Kind of turning purple. There's some acid-base chemistry going on. That's a lesson for another day. This is how
It's
in
a
movies...
wild pool.
In movies, you'll see, like in the movies when they show a potion, it'll often look like this. All right, you ready? I'm going to put the dry ice directly in the water.
Got it. Oh, yes.
What do you see? Take a close look at it.
Oh my gosh, it's like getting sucked up. It's like...
What's happening to the dry ice?
It's pushing out all the air and putting it out the top.
Yeah, it's sublimating. So the air, just like when you boil water, is bubbling.
Can I show Mama?
Huh?
I want to show Mama.
Yeah. Mama,
Mama.
you got to see some sublimation here.
Alright.
We're doing some sublimation.
Whoa! Did you make a potion?
I made a potion.
A witch's brew?
See? And look, you'll actually feel. Put your finger here. Do you think it's going to be cold or hot or warm?
Cold.
Stick your finger right there.
That's warm.
It's warm, isn't it? Isn't that surprising?
So some of you might be wondering, what's the smoke? Is that carbon dioxide? Is that the dry ice? Well, remember, the sublimation reaction is a solid turning directly into a gas, and the dry ice, solid carbon dioxide, is very cold. When it turns to a gas, it too is very cold. When it hits the air just above the water, it actually interacts with water vapor that's in the air. That water vapor is what you see turning. It appears sort of like a fog or a smoke. That's why we can see clouds in the sky, low fog at night. So if you think about it, we're getting 2 changes of state of matter, or almost 2. The sublimation reaction, the conversion of the dry ice from solid to gas, as well as a condensation reaction, condensing the cooling of the warm water vapor from the gaseous state to not quite liquid, but a cloud or a fog as a result of condensation.
Maybe we need to put another piece in there. Get it going. Get even more potion going.
Maybe we can mix a few colors.
There we go.
We should mix a few colors, maybe.
Sure. You want to put some more colors in there?
I'll put some blue. Yellow. Yeah, yellow. Yellow. And I'll put one of each. Ooh.
Trying to make a bubble.
The bubble experiment. 1, 2, 3. Wahaha! I'm mixing all the colors together. Actually, it's not actually all gone.
There we go.
It's
There we go.
floating Woo!
It's working, Mama. Check it.
Oh, yeah.
So you put a bubble on.
Yep.
This is also demonstrating sublimation, right? The gas is escaping.
I wonder if we're able to dye the bubble. I wonder if that works.
Do you
Try
think the dye is going to go...
I think it's...
Very carefully.
Oh, I see on the outside.
Ah!
Oh!
What happened? It went right on through. Why do you think that happened? Too heavy, right? It's a liquid. So I made this special formula of bubble.
A special formula of bubble that's so good that it doesn't pop when something
It's
goes
a little
through
bit,
it.
yeah.
Oh my gosh, that's so stable.
All right, I think we got one more piece. You ready? I'm gonna pop this one. If I can. Hey, get out of the way. Here we go.
Ah.
There we go.
Okay.
Smoke bubbles. Mama, check it out.
This is getting bigger by the second.
Now, do you think it's going to float or do you think it's going to sink?
I think it's gonna float.
Mama, look at it. Oh, it fell.
Man.
Look at that, eh? And you're right. Even though there's a lot of oh, look, that one, a little bit of green stayed on the bubble.
Let me see if I can put some more.
See, carbon dioxide makes up a significant part of our.
And then like it's so strong, it just like.
Like something.
Ah!
So sublimation, pretty cool, huh?
I wonder if we put the glove on that.
Oh, no, but you know what we can do?
What?
We can take that piece out since we're done that experiment. And throw it in here. This is cooler, right? Oh!
Yeah. Way cooler, too cooler.
Boop.
Boop.
Although I think we're almost out.
Yep, we're almost out. Next time, can we order some frozen helium and do it?
Well, maybe more carbon dioxide.
Yeah.
We'll just have to order more fish or something else that's frozen. And that's sublimation.
Muscles?
Um,